Hi everyone. So let me go over this quick review where we have to simplify or express in another way these terms, these expressions, using the rules of exponents and radicals. So if you have an x times x, you know that this is automatically, like from memory, you say that that is x squared. Because actually what's happening is that there's a 1 here, a power of 1, and you add them both, the exponents, so you have a squared here. And the x times the x dot x is the same as when you use parentheses. They both mean multiplication. So this is also x squared. Here, you multiply the coefficients. So 2 times negative 10 is equals to negative 20. And of course, you have m and m. You also multiply them. And similar to this x squared, you say negative 20 m squared. And if you have variables inside the parentheses raised to a power, so you can write them in a different way by separating those variables and raising them, each one of them raised to the same power. Here, there's nothing much you can do because they have different bases here. X and y are different. So you can maybe remove the parentheses and write them as x to the 6th power y squared. And this one, you have the same basis, you have the same variable, so you simply add the exponent. The exponent 6 and 2. So 6 plus 2 is 8, so you say y raised to the 8th power. And here, this is a division between x and y. So x divided by y raised to the 7th power. So you can express that as x to the 7th divided by y to the 7th. Here, we have the same basis. So x to the 10th divided by x cubed or x to the 3rd power. So you simply subtract the exponents, the top exponent minus the bottom exponent. So you end up having x to the 7th power. And then number 9, take a look. Just like what we did in number 7, we can raise both the numerator and the denominator, raise that to the same power. So this is x squared over 9 squared. But 9 squared can still be simplified. So you say x squared over 9 times 9 is 81. And here, number 10, anything except of course 0, it's 4 raised to 0, it simply equals to 1. And next, the same thing. So a bunch of, a combination of integers and variables inside a parenthesis raised to 0, that would be equals to 1. Now, using the law of negative exponents, you can actually write this down as 1 over, so you remove the negative exponent, you just kind of like flip this as being, if you imagine 1 being here, then you kind of flip that 5 from the numerator, you make that as a denominator in order for you to achieve a positive exponent. And you can still simplify 5 squared. So this is actually 1 over 25. And another way you can write this is that you express this, the 9 raised to 5 over 6, you can express it as a radical. So you can remember this by maybe, so you have the radical sign, and then you put the 9 inside, and the numerator of the exponent goes with that 9, and the 6 comes outside. It goes outside of the radical sign. And you can leave it like that for now. So you read this as the sixth root of 9 raised to 5. And here's one thing that it will help you very much later on if you remember that anything that's raised to 1/2 is the same as the square root of that number. So the square root of 49 is the same as 49 raised to 1/2. And of course, you can still simplify this into 7 because the square root of 49 is 7. 7 times 7 is 49. And on number 15 here, if you take a look at this same radical, no, they are different radicals, but they have same roots. So you can actually express it as the fourth root of S and T. Both S and T goes inside the radical symbol. And this too, it's a division, but they have the same root. So you can say fourth root of R over W. And this is the opposite of number 15, right there. So you can express this as, you can separate those two. If needed, you can write them as the seventh root of H and times. You can use the parenthesis or you can use the dot to express multiplication of this two. So seventh root of K. So seventh root of H times seventh root of K. Or simply, or maybe you might want to remove the dot and write it with, what's this? Write it with parentheses like that. So same thing. Okay. And then again, here you have a negative exponent, so you can just flip this position, put it up as a numerator, and you end up having C raised to the third power, or C cubed. Now, this is a combination of a bruise. So look at this. Everything inside the parenthesis is raised to 2. So each of those would be raised to 2. 4 times 4 would be 16, and x to the third power raised to 2 or squared will give you 3. The exponents, multiplying them, 3 times 2, you have x to the 6th power. And of course, 5 times 2, you have now y raised to 10. And you're done with that. And here, same thing. So if multiplying means raising everything inside the parenthesis to the same power here, here, when you have division, you simply divide each corresponding integers and variables. So negative 99 divided by 11 is negative 9. Negative divided by a positive is a negative. And you are subtracting the exponents here. When you have division as an overall operation, you can subtract the exponents of the like bases. So this will become x to the third power because 5 minus 2 is 3. And of course, your y would be the power, or the exponents would be 4 minus 2. So you have squared here. And we have covered all of our examples. So let me just show the whole picture if we could capture that. Okay, we'll make that smaller. Can we, it's dimming. And I'm probably gonna just scroll this down because, okay. All right, so you have a full view of the examples. There we go.